Can you solve this easy LeetCode problem number 231, power of 2? The problem states, given an integer n, return true if it is a power of 2, otherwise return false. There's also a follow-up that says, could you solve it without loops or recursion? Let's start off by taking a look at the examples. So in example 1, we're given n equals 1, and we want to return true because 2 to the 0th power equals 1, so n is a power of 2. In example 2, n is equal to 16, and we also want to return true because 2 to the 4th power is 16. In example 3, n is equal to 3, but we should return false because 3 is not a power of 2. One way we could solve this problem is by starting with the lowest power of 2, or 2 to the 0th power, which equals 1. If n is equal to this number, then we know it's a power of 2, and if not, we can multiply that number by 2 to get the next power of 2, and check if n is equal to that number. And we can keep doing this, checking if n is equal to any of our powers of 2, until our powers of 2 becomes greater than n, because we know it's just going to keep growing, and it was never equal to n. So let's write the code. First, we'll create a variable called power of 2, which will initialize to the first power of 2, which is 1. Then, we'll create a loop while our power of 2 is less than or equal to n. We'll check if n is equal to our power of 2, and if it is, then we'll return true. Otherwise, we'll multiply our power of 2 by 2 to get the next power of 2. And we'll keep looping like this until our power of 2 becomes greater than n, in which case we'll break out of the loop. And if n didn't match any of our powers of 2, then we'll simply return false. Now this is a pretty good solution that's O of log n time complexity and constant space complexity. But remember the follow-up question that said, can we solve this without using loops or recursion? In order to solve this without a loop, we can use bitwise operations, which means dealing with numbers in their binary form. So the number 1 in binary form is just 1, and the number 2 is 1, 0, because each additional digit represents another power of 2. So the number 3 is 1, 1, and the number 4 is 1, 0, 0. Actually, we can get to every next power of 2 in binary just by starting with the number 1 and adding another 0 to the end. So the next power of 2, 2 to the 3rd, or 8, is 1, 0, 0, 0. And every number before the next power of 2 in binary is the opposite, with 0 at the beginning and then all 1s to the right. So if we take every power of 2 and the number right before that power of 2, and we do a bitwise AND operation on it, which means lining up each digit and checking if they're the same, then we'll always get a 0 because the digits are all opposite. So whenever a number n and the previous number n minus 1 are bitwise ANDed with each other, if the result is 0, then that means it's a power of 2. So our solution can be this one-liner, return n is greater than 0 and not n and bitwise n minus 1. The time and space complexity for the solution are both constant. Don't forget to like and follow for more.